All right, getting back to it. So we were discussing the Paleozoic era, which is our ancient life in our eon, right? Remember, our eon is the, how do you say it? Phanerozoic? No, that's Phanerozoic eon. We are in the Paleozoic era. Remember, we had lots of marine life here. It spans from about 500. There we go. While you copy these down, it spans from about 541 million years ago to about 252 million years ago. Many organisms with shells or exoskeletons started appearing. Remember, the prefix exo means outside, and a skeleton is a firm structure, so an exoskeleton is a hard outer body shell structure. So we had a lot of invertebrate animals here, but vertebrates, plants, amphibians, and reptiles evolved into more of sort of what we would imagine today. Much of Earth was covered in that shallow water, so most animals were aquatic. Simple land animals did evolve about halfway through this era. Pangea formed at the end of this era, creating mountains as continental plates collided. Remember, we talked about, or we will hopefully talk about, how Pangea was the big supercontinent where all the continents were together and then they eventually spread apart. But right now we're just at one big supercontinent. At the end of the Paleozoic era, it was marked by a mass extinction. About 90% of all marine mammals and 70% of all land mammals, or land organisms, apologies, I should not have said mammals. About 90% of all marine animals and 70% of land organisms became extinct. Many times when we mark the transition, when one era ends and another begins, it's marked with a mass extinction. You're going to see that as a common theme as we go through these eras. Because organisms during the Precambrian period didn't have bones or other hard parts, there aren't many fossil records to kind of help us discover more about this, so we don't know a lot about this era. Reptiles were one of the few organisms to survive from the Paleozoic into the Mesozoic era. Because they were well adapted to land, scientists aren't sure what caused the mass extinction, though they could have been as a result of the Pangea formation, the lowering of ocean levels, and the formation of deserts. But again, they're really not sure. Some other possible events that could have happened are like volcanic activity, which would have put ash and dust out into the breathable air for these organisms, or there could have even been a small climate change to a colder climate, meaning that the organisms that needed that warm climate just couldn't handle the cold and ended up going extinct. But here's some examples. That's the trilobite that we talked about in the beginning, that very notable structure. We find many fossils of these because they were just well preserved. We see them often in continental areas, which give us the evidence that the Earth was covered in shallow water, because we do have these trilobites, which were marine organisms. Also, brachiopods were common. They're like clams, so they're bivalves. They look very similar to clams. They're different though, but these were very common in this era, as well as some of our early fish, which look very different from what the fish we have today. Although it should be noted that these are artist renditions of fossil remains that we do have of these organisms. So this is just their best estimation of what these organisms would look like based on the few evidence and fossils that we do have from this time. And then this is a frilled shark. So this is what we actually call a living fossil, and this is something super exciting that I'm excited to tell you about. A living fossil is something that was once considered extinct that we actually found living. So we find living fossils really often in our oceans because it's one of our most unexplored places. Remember at the beginning of the year we had the debate, should we explore space? or the sea. We know just about as much in each of the fields. Should we be putting our resources towards exploring space or sea? We debated that. But this was one of those living fossils that they found, and this was an organism likely to have been alive or its ancestors in the Paleozoic era. I have a couple more living fossils. I don't know if they exactly go along with the Paleozoic era, but this is one you should know. This is a horseshoe crab. They're found. You can find them over at the beach. I have. I lost it. It's somewhere. I have a molt of a horseshoe crab. If I can find it, I'll bring it in to show you guys. But that's actually one of the living fossils that we do have. These guys have blue blood, which is really important to us from a surgical standpoint. We'll talk about that another day, though. But these are awesome little guys right here. And then the other living fossil, this is a fish. I can't remember. Let me check real quick exactly the name of this fish. I had it written down because it was so hard to remember. This is a coelacanth. It lives off the east coast of Africa and Indonesia. They were found in the waters of Indonesia. They are also an example of a living fossil. So this is something like a prehistoric organism that we would find maybe back in the Paleozoic age. I told you early land plants were beginning to evolve, like mosses and ferns and cone-bearing plants like our pine trees. This was very not important, but these are the kind of land plants you would have seen at that time. And now we are headed into the middle life, the Mesozoic era, or the age of the reptiles. At the beginning of the era, the continents were joined as Pangaea. Pangaea broke up around the middle of this era. And remember, I said this was called, we named the nickname for this era is the age of reptiles, because reptiles became the most abundant animals because of their ability to adapt to the drier climate of the Mesozoic era. And that happened, that caused that mass extinction. So this spans from about 252 million years ago to 66 million years ago. This would account for about 4% of Earth's history. Again, Pangaea splits first into two land masses and then eventually into the continents that we know today. Dinosaurs evolved during this era, so this is like your Jurassic periods. The first birds and mammals also appeared during this era, although they were mostly small and underground. Think about those dinosaurs for a second and what we know about ecology. If the dinosaurs were our primary predators, mammals would evolve to be very tiny and small so they could evade those predators. Anything larger would likely have been prey for the dinosaurs and therefore just not had a very good chance of survival. Angiosperms, let's see what else we have here. Yep, there we go. So this is what we just talked about. Dinosaurs were very active in this era. The first small dinosaurs appeared in the Triassic period. Larger and more abundant dinosaurs appeared in the Jurassic period. That's why Jurassic Park is called Jurassic Park and not Jurassic Park. Many small mammals and birds also appeared. We talked about that. The mammals were small, warm-blooded animals. The hair covers their body. That's important. We know that, or should know that, the difference between a reptile and a mammal. Reptiles are cold-blooded, meaning they need an outside heat source. Mammals are called endotherms. They can regulate their own body heat. They don't need something else to do it. And they had hair covering their bodies. These characteristics of the endotherm, so being able to control their own heat, and hair help them survive in the environmental changes that we're going to see in a little bit that caused, you guessed it, another mass extinction. We think. We don't know. So I told you back in the Paleozoic era, our coned trees were very common. Our I always struggle with this word. Conifers. Our evergreens were very common during this period. During the Paleozoic period, we did see a switch to angiosperms. So gymnosperms are what we call the word I can't say, the cone-bearing plants, the evergreens, and angiosperms are the other type. Those are our flowering plants. Your conifers, your coned plants. Angiosperms and gymnosperms, so our seeded and flowering plants first appeared. Sorry, I mislabeled gymnosperms. again, so here's our dinosaurs before we get into the end that were possibly, that we hypothesize were around. Just for size reference, we've got a human in there. Humans were not around during the time of the dinosaurs, and it is likely that our elephants were also not around during the time of dinosaurs, because remember we said we only had small mammals at that time, and an elephant is a very large mammal. Okay, so we got a Tyrannosaurus Rex, a T-Rex, we've got the Triceratops there, we got our little dinosaur right there, and some more dinosaurs that I cannot say. But these were times of very, very large organisms. But again, they were reptiles. That's important to note. They couldn't regulate their own body heat. So let's talk about maybe how they didn't make it. Again, here's some more of our aquatic reptiles that we would see. This little guy right here, the ones that look like this is a very common tetrapod that we think maybe brought us from the land to the sea, but that's a whole topic for another day when we talk about evolution. But here's some examples. We've got like a turtle-looking guy right here, and ones with flippers and fins. Those were common. So while these might have been our land reptiles, they were also reptiles of the sea. This little guy, think a bunch of little bearded dragons. This little lizard going around, but larger. So some of their evolutionary ancestors survived this mass extinction to come, but not all of them. Again, here's the plants that we're talking about. So this would have been very flowery is the wrong word. This would have been a time where you see lots of trees with seeds and flowers around. So we're switching from our pine tree type look to more of the trees that we know today that flower and have seeds, like all our fruit trees are seed trees, even like our magnolia trees, which don't have any actual fruit for you, but those are flowering trees, just a different way of reproducing. And then, just like with our end of our Paleozoic era, the end of our Mesozoic era again ended with another mass extinction event about 65 million years ago. Many groups of animals, including the dinosaurs, disappeared suddenly at this time. Many scientists believe that this event was caused by a comet or asteroid colliding with Earth, though that is not exactly proven, supported. Not always supported. So there are other theories flying around about how maybe the dinosaurs lost their lives, but that's okay. The most prevalent theory is that this comet or asteroid collided with the Earth. The end of the Mesozoic era was marked by another round of mass extinctions. Again, we see that at the end of eras and even end of periods as well. Probably caused by a meteor colliding with Earth. It wasn't the impact of the meteor that caused the issue. It was the dust and the smoke in the atmosphere that was really what caused the damage for these organisms. Dust and smoke blocked out the sunlight and altered Earth's climate, which caused plants to die and subsequently caused animals that depend on the plants for food to die. Remember how we supported not too long ago, like just a couple days ago, that the sun is the ultimate source of energy on Earth? Yep, sure was. So when the dust blocked out the sun from the Earth, it caused the plants to stop growing. We talked about this. If you try to grow a plant in the dark room, it's not going to grow. It needs the sunshine to ignite the process of photosynthesis, but they didn't have it because of the dust, and then the plants died, and then when the plants died, the things that ate the plants had to die, or died because they couldn't find food, and then eventually it worked its way through the food webs to eventually even the carnivores were gone. This not only caused the lack of sunlight for photosynthesis, but also it became much colder because the sun wasn't able to penetrate through that dust. So that's why our mammals did so well here and were able to survive. Here's my asteroid. Here's my implosion. If I would have remembered to do sound effects, I would have. And that's possibly some support for it. Here is exactly what I have written, what I discussed. Not all life forms died. Many animals that you see today are descendants from the survivors. If everything died, we wouldn't be here. Pause this, copy it down. join me for our final lecture on the Cenozoic era in a brief second.